This is lesson 5, chapter 5, section 5, all fives right here. So we're talking about complex fractions as well as order of operations here. So let's get into it. We've got complex fractions. All right, it's got complex name, makes them sound kind of difficult, but they're not. They're not as hard as you think they are. All right, so complex fractions are fractions. No, I think this is kind of written. I wrote these notes, but I think I should get rid of the word and put or. Okay. But complex fractions are fractions with a numerator uh, or a denominator. And so, it could be or and. It could be both, but and I'll explain that. So the numerator or denominator or both that are also fractions. That means the top number is a fraction, the bottom number is could be a fraction, or both the numerator and denominator could be fractions. All right, complex fractions are simplified when both the numerator and denominator are, I know this it sounds like a very and like it doesn't seem like an answer, but non-complex, which means they're no longer like the numerator is no longer a fraction and the denominator is no longer a fraction. Maybe the whole answer is a fraction, that's fine. But you don't have a numerator with a fraction, you have a denominator as a fraction. Hopefully that makes sense to you. Okay, so rewrite. So I think sometimes what is a little bit confusing with complex fractions is how they're written. I think sometimes that they don't have a lot going for them with how they're written. So um, it's not always clear, like where is the delineation between the top, like the numerator and the denominator, because that's not always clear. So I'll help at least describe that to you. So like right here, the numerator is a 1, okay? So we're going to write it. So that's a 1 right there. And oh, and by the way, we're going to write this as a division problem because that's really what a fraction is, right? A fraction really is division. So that's really a 1. So I'm going to write that as 1 over 1, okay? Divided by, and it's divided by the denominator, which is 1/2. So 1/2 is the denominator. So that's really what it is, right? Why isn't it written that way? Well, because, this is math, right? You can't have things all like simple, but um, but we have 1 over 1 divided by 1 over 2. So we're just going to keep change flip. So we're going to do 1 over 1, change division into multiplication, and then flip the second fraction, which comes out to 2 over 1, which is just 2. So that's the answer right there. 1 divided by 1/2 is 2, right? All right, number 2, example 2. All right, in this example right here, the numerator is a fraction and the denominator is a whole number. Okay, so we're going to write that out as a division problem. So we're going to have 1/4 divided by 2. And I'll just write 2 over 1. So keep the first fraction the way it is, change division into multiplication, and flip the second fraction. And when you multiply left to right on that one, you get 1 over 8. 1/8. 1 times 1 is the 1, 4 times 2. Okay. So that's that. All right, right here. All right. This one, what do we got going? We got a math problem basically in the numerator. So we should probably just solve that off to the side. So we got 4 plus. Now, let's go ahead and just do this part. The exponents come first. So -3 squared really is 9, right? -3 times -3 is +9, which comes out to 13. So this is really 13. I'll write it as division. 13 divided by 2/3. 13 divided by 2/3. Keep, change, flip here. Keep, change, flip. And that comes out to 39 over 2. See, and notice how the answer is no longer complex. 39 isn't a fraction. 2 isn't a fraction. The whole thing is a fraction. That's fine. That's okay. Some people think like you can't have any fractions, but it's no longer a complex fraction. That's the key. All right, and that is going to be what, 19? If we change that, that's going to be 19 and 1/2. 2 times 19 is 38, plus 1 is 39. Okay, so like on this one right here. All right, so we got a lot going on in this one. So in the numerator here, we have a whole fraction problem. And in the denominator, we have a fraction problem. So we just better solve those separately. So we got 5/9. I'm gonna write plus -7/18. Right there, the denominator is, the LCD is 18. This 18 is a multiple of itself, and 18 is a multiple of 9. All right, now 9 times 2 is 18, right? So I'm going to do 5 times 2, which is 10. 18 times 1 is 18, so I'm going to do -7 times 1, which is -7. This all comes out to what? 3/18. I wrote 16. I think I know why. Because it's going to come out to 1/6 when you simplify it. 1/6. All right, so the numerator is 1/6. I'm just going to put that right there. Let's do the other one. So 1/2 plus 1/8. 1/2 plus 1/8. So the common denominator on this one is 8. The least common denominator is 8. So 2 times 4, right? 2 times 4 is 8. So we're going to do 1 times 4. All right? 8 times 1 is itself, and 1 times 1 is 1. So that comes out to 5/8. All right, so this is, we haven't done everything yet. Seems like we've done a lot, but so far we've got 1/6 over 5/8. 5/8, which is a complex fraction still. Still complex. We haven't changed it out of it. So we've got to do 1/6 divided by 5/8. So keep, change, flip. Keep, change, flip. Now these can be divided by 2. And the other pair cannot. So 1 times 4 is 4. 3 times 5 is 15. And that's it. That's all we can do to that problem. All right, so recipe requires 2 1/4 cups of sugar to make a dessert for 20 people. So let's set it up like this. 2 1/4 divided by 32. All right, and the reason I'm setting it up this way, because this is cups of sugar and this is people. So when I solve this, the reason that I like this, because if you read it from the top to the bottom, it's cups over people. So when we divide this, we're going to get cups per person. We're going to get the unit rate per one person, because if we know what it is for one person, we can figure out what it is for any number of people. For this problem, we need to know 32. So once we once we know how many cups it takes for one person, we'll just multiply that by 32. All right, so the first step is, let's change that into a improper fraction. So that's going to be 9/4, right? Divided by 32. And let's write that as a division problem. So 9/4 divided by 32 over 1, which is 9/4 times 1 over 32. Okay, so no cross canceling on this one at all. I know that it was probably tempting to cross cancel here, but you're not allowed to do that until you have it written as a multiplication problem and you've flipped the second fraction. No cross canceling until you've done that. And this one doesn't have any cross canceling. All right, so this comes out to 9 over 128. Okay, so this basically means it's 9 over 128 cups, which is kind of hard to measure. You're probably not going to do that per one person. Right? So it's a very small amount cups of sugar per person. So now what we have to do is just multiply that by 32, right? Or sorry. Oh, what did I do? Oh, I did this wrong. Never mind. I have to start all over. I bet you were screaming at the screen. Let me start over. I should have done 20. Sorry. That should have been 20. I did 32 for whatever reason. Sorry. Right there, I got to start over. So we're going to do 9/4 divided by 20. All right. Pardon me. 9/4 times 1/20th. And still, even if we do it this way, we still don't get any cross canceling that we can do. So this comes out to 9/80. All right, so that's 9/80 cups of sugar per person. Okay, so now what we have to do is we have to multiply that by 32. So sorry about that, wasting your time. So 9/80 times 32 over 1. Now this can cross cancel. So 32 and 8, those can be both divided by 4. Oh, they can be divided by 8. That's even better. We can divide by 8. So that becomes 10. And that becomes 4. All right, and we can cross cancel again. We can divide by 2. Right? We can divide by 2. And we could have divided everything by 16. I didn't see that right away. So we get 2 and we get 5. So now we have 9 times 2, which is 18. 5 times 1, which is 5. Now change that into improper fraction. That comes out to 3 3/5 cups. So that's how much sugar is going to be needed for 32 people. 3 3/5 cups.